Welcome to classes on physical chemistry, and it is the chapter electrochemistry, H.Sc degree second year. And today I am going to explain electrolysis, cells, batteries, and if possible, Nast equation. So first of all, electrolysis in a very simple way. Let me define without writing many things. In a one line definition is earlier in the chapters of the same chapters we explained chemical energy give rise to brings about the electrical energy. Now here in the electrolysis the matter is a bit different or reverse, where electrical energy is generated or the chemical change occurs due to the electrical energy. When electrical energy is passed in a solution of electrolyte where there is cathode, the ions moves in different cathodes and they decomposes or the changes. So the changes of the ions in the electrolytic solution is brought about by electrical energy, and hence the topic is electrolysis. Am I right? This is electrolysis. So whenever you talk about electrolysis, we shouldn't forget about Faraday's first law of electrolysis. Very simple, nothing to explain in details. The first law of electrolysis, the masses of the substance deposited at the electron is directly proportional to the amount of charge passes into the electrolyte solutions. And mathematically, if you write mathematically, we can write W is proportional to Q, where W is the amount of substance deposited at the electrode and Q is the charge. And you know that Q is equal to IT. It is known to you all, where I is equal to current T is time in second. So W is proportional to Q and is proportional to I into T. When we omit the proportionality sign or remove the proportionality sign, there is a constant, and that constant equal to Z. So you write W is equal to Z into IT, and that proportionality constant Z is also called electrochemical equivalent or ECE. So from the first law of electrolysis, that is Faraday has proposed the law, stated the law as W is proportional to Q, when where Q is equal to IT and W equal to Z into IT, where Z is a constant called electrolytic electrochemical equivalent, and T equal to time, W equal to mass of the substance deposited, Q equal to charge. Am I right? So this is very simple. When amount of the charge passed through electrolytic solution with electrodes, a setup of electrodes, then amount of the substance deposited at the different electrodes is directly proportional to the amount of the charges. More the amount of charges passed into the electrolytic solution, more will the amount of substance deposited at the electrode. And where Q is equal to IT, we can replace Q by IT, and the Q is equal to some constant Z equal to IT, where Z is equal to electrochemical equivalent. Let us now define what is that Z. Define that W is equal to Z into IT, and if you assume current is equal to 1 ampere and T is equal to 1 second, so W equal to Z. Now from this relation we can very easily define electrochemical equivalent, that is defined as the mass of a substance deposited in the electrodes when 1 ampere current in 1 second is passed through an electrolytic solution. Very simple. That is called electrochemical equivalent, that is Z. So now let me explain a very important term, 1 Faraday. It can be defined in many ways. Let me first define in the first way. The quantity of electricity that causes depositions of one equivalent mass of a substance is called 1 Faraday. It is 1 Faraday is that amount of charge which, when passes in the electrolytic solution, will allow the deposition of the metallic substance is equal to its equivalent weight. The amount of charges when passes into the electrolytic solution will cause the fall or depositions of a metallic substance is equal to the weight of its equivalent weight. That is, 1 Faraday is equal to 965,000 coulomb. That coulomb charge is called 1 Faraday. And if this amount of charge is passed in an electrolytic solution, it will allow the deposition of the metallic substances in the electrode is equal to its equivalent weight. Now, what is equivalent weight? Equivalent weight equal to mass divided by N. N is equal to valency of the metals of the substance. So, whatever is the mass, say if it is zinc, you give the mass of zinc is above, and its valency 2 divided by 2. Whatever amount is, the amount is called equivalent weight, and that equivalent weight will deposit in the solution when that amount of charge is passed through the solution, and that is called 1 Faraday. So 1 Faraday is equal to this. So you can write equivalent weight is equal to m by n, n is equal to valence of the metal, or Z is equal to electrochemical equivalent. Earlier I have already defined is equal to E by F. So a equivalent mass divided by Faraday, that again E is equal to m by n. In place of E you put m by n, it will be m by n into F. So Z is equal to E by F is equal to m by n F. So in other way, let me define. So you see the charge of one electron, the charge of one electron is equal to 1.6 into the 119 coulomb. It is known to you all. The charge of 1 mole of electron, that is mole u naught 6.02 10 to the 23, that charge into 6.10 to the 23, if you multiply this, you will get 96500 coulomb. So that is quantity of electricity 96500 coulomb is called 1 Faraday. Am I right? This is another definition of Faraday. Again, it is very simple things. You assume two electrolytes. Am I right? In one electrolyte, say zinc, the electrode one is zinc, and the electrolytic salt is zinc sulfate, another is copper and copper sulfates, and you connect it to a current, and you pass same amount of current in the two electrolytic solutions of different electrolytes. So it is seen the amount of the substance of, say it is zinc and it is copper, the two metals when it will deposited in the electrodes, the ratio of the depositions of two metal, say if zinc is W1 and this is W2, the ratio of their equivalent masses or electrochemical equivalent, ratio of the electrochemical equivalent are the same. The W1 by W2 is the ratio is again equal to E1 by E2, equivalent mass, electrochemical equivalent is E1 and E2. So when same quantity of electricity is passed through two electrolytic solutions connected in series, the amount of the substance deposited at the electrodes are in the ratio, their ratio of their equivalent masses or ratio of their chemical equivalent. W1 is equal to W2 is equal to E1 by E2 equal to Z1 by Z2. You can write in this cell. This is the second law of the Faraday's second law. So this is a new things you may not get normally in the books, and it is very simple things. You see that if you combine the first and second law, Faraday's second law, we will get that from the first law we'll know that W equal to Z into Q. Am I right? Again, Z is equal to E by F. Already I have given a bit earlier. E by F equal to Q into. You replace it. E, keep it E here, Q here. Q by F is equal to E. Again, E is equal to M by N. Earlier I have given you. So Q by F is equal to M by N. Again, Q is equal to IT. That is IT is equal to M into F into N, where N is equal to balance it. That is W is equal to IT M by F N. This is the combination of first and second Faraday's law of electrolysis. So here let me explain one of the important thing, that is cathode and anode. So anode and cathode is in the modern concept or the convention. We can write cathode, anode, and cathode, anode. It is the path of the electrodes where oxidation occurs is called anode, and the path or the electrodes where reduction occurs is called cathode. Oxidation means loss of electron and reduction means gain of electron. Loss of electron is oxidation and gain of electron is called reduction. So the electrodes where oxidation occurs is called oxidation, and the electrodes where gain of electron occurs is called reduction. So you are asked to write the product of electrolysis when copper chloride in aqueous where the electrodes are platinum. Mind that platinum is non-reactive. No reaction occurs in the platinum. So what's happened? In the electrolytic solutions, we get copper to positive aqueous. This is aqueous and this is aqueous. Am I right? These two ions occurs in the electrolytic solutions. So at anodes, what's happened? It is deficient in electrons. That's why the loss of electron will occur. It will lose 2 electrons to give you chlorine gas. It will evolve out, and in cathode and copper 2 positive, it will takes electron. It takes electron, accept electrons. Is cathode mean reductions, gain of electrons, gains 2 electrons to give copper solid. Am I right? And if you are asked to give the Gobarel reactions, you adapt this to twice chloride negative plus twice chlorine. This and can solve this two, you will get chlorine gas and copper solid. This is overall. You only add up and these two cancels out. This will give you overall reactions. So first question is over. Electrolytic product of copper chloride in aqueous solutions using platinum as electrode. Again, there is one, the important point is to be noticed is that when there was a platinum electrode, there was no reaction involved with the platinum. But here, copper is electrodes. So, in one place, copper is electrode, other places, copper is electrode. Am I right? And the solution copper sulfate, say, copper chloride, say, copper 2 positive is there. So, very often at anodes, what's happened? Anode is where oxidation occurs. So, here, copper, anode, this is copper. So at copper solid, that transforms into copper 2 positive ions and goes to the solution by losing out the electrons. Here no platinum is there, copper is the reactives. That's why it loses out electrons, that is oxidation occurs at the anode, and it give you copper 2 positive aqueous plus twice electrons, and copper 2 aqueous in the solution will accept electron from the cathode to give you copper 2 positive, copper as solid. So this is the thing you assume. When copper is electrode, so reactions of copper to copper 2 ion by losing electron, oxidation occurs at anode, and at cathode copper 2 positive will accept electron, and here is electron rich center, it will take up two electrons to give you copper as a cathode. Here again things minutely follow. Then silver nitrate is in the solutions. When silver nitrate in the solution, in aqueous solution, that backs up into silver positive aqueous plus nitrate 3 negative aqueous. Am I right? So here your platinum is a not reactive one. It will not involve in the reactions in the in the electrolytic solution. So what's happened at the cathode? At the cathode, that silver positive ion will come forward. It is rich in electron. Am I right? It will take up one electron from cathode to give you silver. This. And now what will anode? So in the anode there is negative charge and NO3 positive, NO3 negatives, and there is also water, but this has less mobility. It cannot move through anode. So water backs up to give you this, and 4 positive and 4 electrons. That's why the reaction is a bit different. This is the due to NO3 negatives and water's liquids, and it backs up into this in the anode. So here you see that at anode, since silver is reactive, am I right? And that silver is not is platinum, so silver electrode it is a metal, so it will lose electron. It's anode. Anode is the oxidation loss of electron. So at oxidation, when it is a reactive silver electrode is used, then this silver electrode, then from this silver electrode, that is silver electrode, silver passes into the solution as ions and lose electron, and that's why at anode that gives silver positive aqueous and loss of one electron oxidation occurs, and at cathode, and this silver positive once again move, that is takes up one electron, give this one. So these are the 4 or 5 different type of products of electrolysis, very often asked in the entrance, also in the class exams. Short question very often asked, so minutely follow. There is a bit difference when platinum and when metals are used as electrodes. So cells are of 2 types. One type of cells are called primary cells, and other types of cells are called secondary cells. Now the cells which provide electricity, in which the product cannot be reversed into the reactant. So when the reaction occurs, it gives reactant to product, and that product cannot be reversed to the reactant. Means the cell, when is used, it gives electricity, but it cannot be further charged to once again give the electricity. Non-chargeable cells are called primary cells. So what are the examples of primary cells? So Daniel cell, dry cell, mercury cells are the example of primary cell. Now dry cell. One of the very important dry cell is Lachlan's cell. So this is the very important thing you should know, and nothing elaborate is known required to known by you. Just you simple see that in Lachlan's cells, it is a dry cell. Lachlan's cells, anode is zinc and cathode is the graphite rod surrounded by the powdered MnO2 and carbon. Am I right? And the space between the electrodes are filled with ammonium chloride and zinc chloride. and this is actually electrolytes. So three things you should know. One is anode, other is cathode, and other is electrolytes. These things are electrolytes, this is cathode, and this is anode and cathodes. And then you should know the reaction at cathode, reaction at anode, and the overall reaction is add up, you will get overall reaction. Am I right? Very often asked, write the cathode reaction, anode reaction, write the anode, write the cathode, write the electrolytes. This is electrolytes. Am I right? So here at anode, if the oxidation occurs, means zinc, this loss of electron will occur at the anode, and zinc 2 positive in aqueous will becomes Zn2 plus MnO2 plus NH4 positive ammonium chloride, NH4 plus and Cl negative, and here NH4 positive plus 1 electron is MnOOH plus ammonia, where it is a reduction, because if you find the oxidation state of Mn, you will find it is 4, and if you find the oxidation state here is 2, then Mn2 manganese 4 plus 2, you are getting Mn2 plus, means some accept of electron, 2 electron is accepted by this, that electron, where the gain of electron occurs is called cathodes. Electron reduction process occurs at the cathode. So here these things happens. So this is all about Laplace cells. So before that, I should have mentioned you the Daniell cell, but besides explaining Daniell cell in a separate way, I am comparing Laplace cells, dye cell, and other dye cell Daniell cell. So Daniell cell, it is as a galvanic cell where there are two containers. One contains zinc sulfate and others contain copper sulfate, and there is sulfuric acid in the as a electrolytes, and where zinc, and there is a zinc as electrode and copper as electrode. Am I right? So there are two things. One, zinc and copper is cathode and anode, but and here due to the chemical change occurs, it gives energy, and that energy is produced as light, electricity. So chemical change is transformed into electrical energy in this way. But here the French chemist Laplace discovered and patented the cell in 1866. Now here anode is zinc, and cathode is copper. Here in Laplace cells, a bit earlier I have shown you, and anode is zinc and cathode is MnO2 plus Cn, graphite rods. And here the reduction occurs as copper 2 plus E becomes copper as reduction reaction. Here in Laplace cells, 4 ammonium 4 2 becomes 2 by accepting twice electrons. Here usually the 1 volt in the Daniell cell, and it is of 1.4 volt, and here electrolyte is sulfuric acids, and here electrolyte is ammonium chloride. By way of difference of two dry cell Daniell and Laplace cells, you can very easily understand what is Daniell cell, what Daniell cell is. The important things in mercury cell is what is the anode, what is cathode, what is electrolyte. Reaction is anode, reaction is cathode, or barrel reaction. Adapt. This is the things. So you see here anode is zinc mercury amalgam and cathode is paste of HgO and carbon powder, and electrolytes is the paste of potassium hydroxide and zinc oxide. And in anode reaction, zinc mercury plus twice OH negative gives you zinc oxide as solid plus water plus twice electron. And here in cathode, HgO plus twice water plus twice electron gives you mercury liquid plus O twice OH negative. Overall reaction is adapt, and you please try to find out this one. Please try to keep these things in your mind. Otherwise, you can't answer in the questions answer in the exams. So you should know the main things is anode, cathodes, electrolyte, anode and cathode reactions, and overall reaction. This is all about your mercury cell. So this is about secondary cells. Secondary cells are nothing but the capable of charging. Primary cell are those cells which cannot be charged, where the products can be reversed back into the reactant. That is, charge cannot be done. Non-chargeable cells are called primary cell. Now we are discussing about secondary cell. Secondary cells are those cells which are capable of charging after discharging again and again. That can be charged and to gain its previous position. Again we can use. Again it is discharged. Again we charge it. Again it is used. Means it is chargeable. And these secondary cells are two types of secondary cells are mentioned in their syllabus, and it is lead storage battery and nickel cadmium battery. And what is lead storage battery and nickel cadmium battery? Let me explain one by one. So the important things here you not need to know is the lead storage battery, and which is very largely used in a day-to-day life as the lead storage battery. Here anode is the lead and cathode is the grid of lead packed with lead oxides and electrolysis 38% sulfuric acids. Now what is the anode? Here anode lead oxide plus sulfate, 2 negative lead sulfate plus twice electrons, and cathode is lead oxide plus sulfate plus 4 hydrogen plus twice electron equal to lead sulfate plus twice water into liquids. So if you add up all this, you will get the overall cell of the reactions. So this is all about the lead storage battery. Next one is nickel cadmium battery. So not much about is required to learn about nickel cadmium battery, and you need to know is the overall reaction. So the here lead cadmium battery, so you lead cadmium solid plus nickel OH whole thing 3 gives you cadmium oxide solid and twice nickel OH2 plus water liquid, and this is sufficient for you to load lithium cadmium battery, and this is the reaction occurs in nickel cadmium battery. Next part is your fuel cell. So galvanic cell. The fuel cell is nothing but a galvanic cell designed to convert energy of combustion of fuel like hydrogens and methane, which is bubbled through the porous carbon electrodes. Here the inner reaction is twice hydrogen gas plus 4 OH in aqueous 4 water liquid plus 4 electron, and that 4 electrons is here being used here. Here oxygen is at cathode, oxygen plus twice water plus 4 electron equal to 4 OH aqueous, and you just add up both these two, you will get the overall reaction in the fuel cell. This is all about fuel cell. So due to lack of time and the class has become the lengthier one, so this part could not be explained at this class, and one topic at corrosion and Nast equation left out unit will be discussed in the next class. So hope you have understood the class, and if you find the class more interesting and valuable, you don't forget to subscribe the class, and in the next and the last class of the electrochemistry I will discuss about Nast equations and corrosion in details, and hope you will find the class with full of information. Thanks for watching the class.